Good day everyone! So we are here to tackle about balancing redox reaction in basic solution. So I have here a few steps for you to remember. These are those. So these are the basic steps in balancing redox reaction in basic solution. Okay, copy it on your notebook if you have time. So I'm going to give you the answer last time.
This is the answer for my previous video regarding the balancing of redox reaction in acidic
This is the
solution.
answer.
So for the challenge, this is the answer in my previous problem. Let's take a note. Okay, today we're going to discuss about redox reaction in basic solution. So here is the sample problem that we're going to study today. So we have here there bismuth hydroxide plus SnO2 negative 2 will produce
This
bismuth
is the
metal plus
answer.
SnO3 negative 2. So for the step 1, we need to verify the reaction as a redox. So let us try to look at the oxidation number of each so that we can identify whether it's a redox or not. So for the bismuth, we have there here we have bismuth from the bismuth, so we have here 3, so obviously that is positive 3. For this one it is a free metal, so that is 0, so that is a ground state, so the charge is 0. So next we have the tin. So we have here the charge would be positive 2. How do you get positive 2? We have here oxygen is always negative 2 when they are used for the second element, so negative 2 times 2, that is negative 4. We have an excess of negative 2. What number is to be added to negative 4 so that we have negative 2, that is positive 2. Next we have here uh, oxygen. Here we have 2, negative 6. So that is an excess of negative 2. What added is that will be positive 4. So if there are things that is decreasing, so positive 3 to 0, so that is a reduction process. On the other hand, we have positive 2 to positive 4, so there's an increase, so that is oxidation process. So we are already done with verification of whether it is a redox or not. So we're sure that this is a redox reaction. Let us proceed now. So step number 2, break the reaction into half. So the reduction process is that one, and we have the oxidation process is this one. So after breaking, we need to follow step 3, that is balancing the mass. So for the reduction process, so we have there add hydroxide for an area needing oxygen. So try to look at this one. This is bismuth hydroxide and we have bismuth. So on the right side, we are lacking oxygen. So here we have 3 oxygen. So to comply with that, we need to add 3 hydroxide group. Now, so we have done with that. So we have a balanced mass for the reduction process. For the oxidation process, we need to add 2 hydroxyl group for area needing oxygen. So this one is 2 oxygen, this one is 3 oxygen. So we need here 2 hydroxyl group. So we're going to add to hydroxyl. So when we add to hydroxyl, we need to balance that by adding a molecules of water. So add water per every to hydroxyl. So in this side, we're going to add a molecule of water. So we already satisfied the mass needed because it's already balanced. So if you check it, it's already balanced. Let's proceed. Step 4. Balance the charges. So to balance the charges, inspect its existing charges. And uh, here we have 0, and here we have 0 plus 3 times negative 1, so negative 3. So basically, we have here a negative 3. So add an electron to the left. So in here, we already add an electron so that we can have both charges is equal. So I add here an electron. Is it clear? So let's proceed. So for the other process, so in here, we will notice that we have here 2 times negative 1, so that is negative 2. So we have here 2 times 1, that's negative 2. So that would be here, we have here 2 times 1, negative 2. In here is 0. So we anticipate we need to add 2. That's negative because we have here negative plus negative 2 plus negative 2, that's negative 4. Only in the product we have negative 2. So basically, we need a negative 2. To satisfy that, we need to add now an electron, okay, at the right equation. So to balance it, we need to add 2 electrons. So we have now the balance charges. So after balancing the charges, we're going to proceed on number 5. That multiply the half reaction by the correct factor. So what shall we do then? So find the common multiple of the electron added. Since we have 3 and 2 are added electrons, we will 6 will be our LCM. By then, the factor to multi to multiply will be 2 and 3. So let us look at this one. So that's it. So in here, since the LCM is 6, so to satisfy that, this upper equations will be multiplied by 2, while the lower equation will be multiplied by 3. So let us multiply first the upper equation. So let us have that. So that is 2 times 3, that is 6. And 2 multiplied by 1, that is 2. Then 2 multiplied by 1, that is 2. And 2 times 3, that is 6. Distributive property. Now, for the second equation in here. So there you go. So 3 times 2. So what's the answer? So that would be 6 here. 3 multiplied by 1, that is 3. And 3 multiplied by 1, that is 3. And again, 3 multiplied by 1, that is 3 here. And again, 3 multiplied by 2, that is 6. So we have already multiplied and para procedure number 5. Let us proceed now on the next procedure. And that is add and eliminate common species that are appear in both equations. So let us look at this equations. So what are those species that appear on both sides? So when you say both sides, that means a reactant and a product. So we have the first group, we have the 6 electron and another 6 electron on the product. So that would be cancelled. Then another thing is the 6 hydroxyl group are both appearing in the product and in the reactant. So we're going to eliminate that later. Then said add. So we're going to add what's left. So we have there 2 bismuth hydroxide plus 3SnO2 minus 2 will produce 2 bismuth metal plus 3SnO3 minus 2 plus the water is left, so 3 molecules of water. So next is just merely checking. We're going to check whether it is balanced or not. Let's see. Check the final result for mass and charges. So first, let us look at the mass. Let's count. For the bismuth, we have 2 here and we have 2 here. So balance. How about tin? So for the tin, we have 3 times 3. 3 times 1 is 3. And the other side, 3 times 1 is 3. Next, oxygen. So for the oxygen, here we get 2 multiplied by 3, that is 6. Then 3 multiplied by 2, that's 6. 6 plus 6, that is 12. On the other side, we have 3 multiplied by 3, that's 9. Then we have 3 multiplied by 1, that is 3. So 3 plus 9 is 12. How about oxygen? That is balanced already. So we have now the hydrogen. Hydrogen, so we have 3 times 2, that is 6. And then here we have oxygen, hydrogen, 3 times 2, that is 6. So we have a balanced mass and atom. So let's proceed now with the charges. So there's no charge at 0. That is 3 times 2, that's negative 6. And here, that is 0. And here, that is 3 times 2, that is negative 6. And for the water, that is 0. So we will notice that we have a balanced mass and balanced charges. I hope that you learn how to balance a redox reaction in basic solution. Now, as a tip for every one of us, if you don't know whether it is acid or base, we simply balance the reaction as if it were in acidic solution, because it is easier to balance in acidic solution. Goodbye everyone. See you next time.